Question says, what is the major disadvantage in using NRZ encoding? Let's look at the solution point-wise. NRZ represents non-return to zero. Code shares the property that the voltage level is constant during a bit interval. That means if this is a bit 1, we can see the voltage is constant. This is bit 0, and again we can see the voltage is constant. That's what point 1 is saying. Point 2, high level voltage equal to bit 1 and low level voltage equal to bit 0. This is bit 1, that means it's a high voltage, and this is bit 0, that means it's a low voltage. Now, the main disadvantage. The main disadvantage is that the synchronization of the transmitter clock with the receiver clock gets completely disturbed. When it gets disturbed, when there is a long sequence of zeros or ones. That means this is transmitter sending the signal, this is receiver receiving the signal. In this we can see there is a long runs of zeros, right? When receiver receives the signal, at this point, receiver will come to know, yeah, now zero is starting. And at till this point, receiver will know that, yeah, it was zero. But how many zeros were there, receiver will not be able to identify. So how many zeros were there? Receiver will don't know how many zeros were there. So this is the main problem. This is the major disadvantage. So there is a disturbance in this synchronization between transmitter and receiver. Now, part 2. How does RZ encoding attempts to solve the problem? In RZ encoding, the binary data, that is zeros and ones, is represented by a pulse having transition rather than constant level of voltage. If we see in this figure, there is a transition. Means for ones, we can see there is not a flat line, rather there is a transition, right? That's what point 1 is saying. Now point 2. In RZ, transition happens exactly at the center of the bit period. If we see any of the bit, we can see from high, it comes to 0 at the center. For 0, we can see it was at low, and now it comes to 0 at the center. That means the transition is happening at the center. For this 0 also, we can see transition is happening at the center. For high also, we can see the transition is happening at the center. Third point says it uses 3 values, positive, negative, and 0. We can see this is positive, this is negative, and this is 0. Hence, it is known as return to 0. Why it is called return to 0? Because we can see for every bit, whether it's 0 or 1, for 1, it is starting from a high voltage and coming back to 0. For 0, it is starting from a low voltage and coming back to 0. For every bit signal, you can find this. And to be specific, this is polar RZ. There are 3 types of RZ encoding: unipolar. If you want, you can write this point also: polar and bipolar.